In this video, we are going to continue learning how to write chemical formulas or write names. In particular, now we are going to learn how to name binary compounds with metals that have variable charges. The metal elements that have variable charge, the majority of them live in the area of the periodic table known as the B group, which means that these are the elements that are known as transition metals. Notice that there are four metal elements: tin, antimony, lead, and bismuth, that do not live in the area of the transition metals, but behave like metals with variable charge. Additionally, there are three exceptions when it comes to metal elements that live in group B that do not have variable charges. Those are zinc, which is always positive 2 cation, cadmium, which is always positive 2 cation, and lastly, silver, which is always positive 1 cation. Let's now practice if we're given the name of one of these elements that have variable charge, how do we write their chemical formula? It is important to note that when it comes to metals that have variable charge, the charges are going to be given in parentheses by a Roman numeral. So for example, if we look at the first example that we have, which is nickel 3 oxide. I don't have to think of where is nickel in the periodic table or what is nickel's group. When you have elements with variable charge, the Roman numeral tells you their charge. So in that first example that we have, we're going to follow the 4 steps given a name to chemical formula that we learned previously in the chapter. Nickel 3 means since nickel is a metal, it's going to form a cation, so I write its symbol. Ni is nickel. Roman numeral 3 tells me that nickel is positive 3. Then I have oxide, which refers to the nonmetal oxygen. Since oxygen lives in group 6A, it has a charge of -2. As we learned previously, we are going to take the value, the number of the charge, and we are going to make it the subscript, only the value, not the sign. The 3 in nickel becomes the subscript of the oxygen, so that means that this is Ni2O3. If you're not familiar with Roman numerals, you can see that in the slide, I gave you the numerical value for Roman numerals 1 through 5. Let's go through the next example. We have tin 4 chloride. First, we write the symbol for tin, which is Sn. Roman numeral 4 means that tin is positive 4. Chloride refers to chlorine with a -1 charge because it lives in 7A. When we take the number and we make it the subscript of the other atom, then we find that our answer is going to be SN1Cl4. But because the subscript of 1 is always submitted, our final answer is SNCl4. Let's do one more example. Well, actually, let's do 2 more. Let's do the bismuth and the iron example. Next, we have bismuth 5 sulfide. Symbol for bismuth, Bi. Roman numeral 5 means that it is 5 plus. Sulfide refers to sulfur, which because the sulfur lives in group 6A, it is always -2 charge. When I exchange the value, as you have seen that I illustrated in the other one, we have Bi2S5. The last example that I'm going to do is the iron 3 phosphide. Iron, its symbol is Fe because it has a Roman numeral 3. That means that there's a +3. Phosphide refers to phosphorus with a -3 charge because it lives in group 5A. As we can see, if I add +3 and -3 because they will cancel each other, my final answer here will be FeP. The other way to do this is that I can say, well, at first I will write Fe3P3 when I take these values and I make it the subscript of each other. And because 3 is divisible by 3, then we can see that when I divide those subscripts, I get Fe1P1. When I take the subscript of 1 away, because the subscript of 1 is always omitted, we can see that we have the same answer. I'm actually going to do the last the last example also. Let's do cobalt 4 selenide. When it comes to cobalt 4 selenide, cobalt is CO +4 because of the Roman numeral. Selenide, since it lives in 6A, is -2 charge. When I take this number and I put it as the subscript of cobalt, I take the 4 in cobalt and make it the subscript of the selenium or selenide. I find CO2 Se4 as my answer. In this chemical formula, we also have to apply rule 4, just like we did in the iron 3 phosphide example. Since cobalt subscript is 2 and is divisible by the subscript in selenium, that means that then cobalt subscript becomes 1, selenium subscript becomes 2, and since a subscript of 1 is omitted, the correct chemical formula for cobalt for selenide is COSE2. Let's do chemical formula to name. You can see that in the red box, it has the parameters of how we go from chemical formula to name. Similar to what we learned previously for naming binary ionic compounds, the first word is going to be the name of the metal. Then in parentheses, we're going to do the Roman numeral for the charge of the metal. Lastly, we're going to do the nonmetal stem followed by the suffix IED. I will do several of the examples that we have in the following slide so we see how we do this. One of the most important things when you have chemical formulas in which the metal that you start with is one of those metals of variable charge is that you split that chemical formula into its corresponding ions. We only have to do that for chemical formulas where our metal has variable charge. To remind you, the metals that have variable charge are transition metals except zinc, cadmium, and silver. And then the other elements that have variable charge include tin, antimony, lead, and bismuth. Make sure that you review that. So if you look at the chemical formula for letter A, and I'm just going to rewrite it, Fe2O3. If I'm trying to break this into ions, all I'm going to do is reverse the process that we utilize for writing chemical formula. What that means is that this subscript of 2 used to be the charge of the oxygen. This charge of 3 used to be, or that subscript of 3, I should say, used to be the charge of the iron. So by basically reversing the process of writing chemical formula, I can write Fe plus 3O minus 2. And if we do the crisscrossing that we have done before, meaning that this 2 goes here and this 3 goes here, you can see that that returns us to the original chemical formula that was given. Next, you need to observe, does your nonmetal anion have the right charge? And indeed, it does. Oxygen is always minus 2. Only then we can name our compound. So the name for this compound will be iron, Roman numeral 3, oxide. Let's go over letter B. Our chemical formula is FeO. We can observe that there's no numbers written next to Fe, which is iron, and next to oxygen. That means that there is an implied value of 1 next to it. If we do the same process in which we assign the value back to the ions, we can observe that at first we will be writing Fe plus 1, O minus 1. But as we saw in example A, oxygen is not minus 1. Oxygen is always minus 2. So in this case, we have to erase those charges and then think about why is it that there were no subscripts. If we know that oxygen is always minus 2, it can be suspected that the reason why there are no subscripts in this chemical formula is because the charge of the iron cancel the charge of the oxygen. And when we do that, meaning assign to iron a plus 2 charge, we can rationalize that if we take these ions and they cancel the charge, indeed, we get this chemical formula as the final answer. Now we can name our compound, which in this case is going to be iron, Roman numeral 2, oxide. Let's go over letter C. In letter C, we have Cu2S. We can see that there's not a number next to the sulfur, so we can assume that there's a value of 1. And then as we have done in the other 2 examples, this value of 1 used to be the charge of the copper. This value of 2, that is the subscript in copper now, used to be the charge of the sulfur. When we write the chemical formula for the ions, this is Cu plus 1, S minus 2. If we revise the periodic table, we see that sulfur lives in group 6A. That means that sulfur has a charge of minus 2. So it makes sense that these ions made this chemical formula. So now we can name our compound. This is going to be copper, Roman numeral 1, and the name of that nonmetal ion is sulfide. Remember that when it comes to writing Roman numerals or writing the name of a compound given the chemical formula, capitalization of the metal name is optional in exams. When it comes to the Roman numeral, you can place the two lines or you can just leave them without the two lines. At least from my point of view, that will count as a Roman numeral. But remember that in the previous slide, we have the correct notation for the Roman numeral if you need to revise it.